Okay, me again. Yeah, so this is talking about open polar radar, which has really been led by John Payton, who is just recovering from too much time in Greenland. Of course, he's into myself. And so this really goes to the moving beyond the bed map, which is, and bed machine, which is a big thing, and trying to extract all the data that we have from all these different complex radar data sets. We've got vast amounts of them. It's critical for understanding polar regions, but it's scattered through the international community, and the complexity is enough that everybody's reinvented the wheel multiple times for all the right reasons. But we're trying to reconcile everything so we can get beyond just the ice thickness and start getting into things that will support things like an architecture and other investigations of what's going on glacially. I've essentially recycled John's talk from AGU, and we haven't achieved a whole lot due to field work, but we're trying to unify the data products and getting into the raw radar data so you can go in and reprocess these in standard ways and understand what's going on and remove the black box components of what's going on. And then unify software development, enabling us to be open source and distributable, and come up with a common data serving interface. We have data scattered across the planet, literally. We've got stuff in Zenodo, the Australian Antarctic Data Centre, USAT DC, NSIDC, and that's just us. And in order to find where the data is, we need a more unified approach. And the coverage is, Greenland was more straightforward. It was quite enabling for Joe McGregor to do his great layer mapping exercise in Greenland and then pull a bunch of parameters out of it. But we, of course, as represented here, we have a diversity of systems, approaches, and data of different vintages in Antarctica and many different line kilometers. So, and even the crisis data in Greenland, there is a whole bunch of different versions of processing and setup of the aircraft with different levels of documentation. So we're trying to reconcile all that. These are some details about building on what the existing infrastructure that Crisis currently has with their Open Polar server, where they currently serve the Crisis datasets, which many use. And we're trying to make sure that all the other formats are compatible with this open source interface for distributing the data. It's not intended as a master repository. It'll likely still point to where all the different data sets are, but at least you can find it. And so currently the stage that we're in is that Lamont and ourselves are working with John to provide our processing flows, to provide insight into how the data actually gets processed. Some details on exactly how to do this. This was one of the last rounds of the EarthCube project, which is an NSF initiative to build tools for managing big data. And they just had their last meeting a couple of weeks ago on a lot of the processes, including things like notebooks and using those as supplementary data, so you've got your full processing flow to understand how you actually came to the result you did, as opposed to reviewers taking it on faith. And then the fair approaches for how to deal with data, making it findable, unique IDs, which is something that regular thing whenever I see a paper, I say, please put the name of the line in your radargram caption, please, so you can trace it back. Some of this, I mean, the data standards will help, but I think there is a certain level of community training and reviewer training to make sure that we're disciplined when we're actually referring to data sets. Standardizing the metadata, making it interoperable, and of course reusable. We're trying to move beyond, just a single ice thickness. Things like an architecture really demand being able to look at multiple values within a fast time record, and also bring out regions. That's other levels of complexity. It's not clear whether we'll get to this in this first 3-year phase of Open Polar Radar. We want to make sure that we're compatible with GIS. QGIS is an obvious tool. I know of some parallel proposals which are nearly funded, which are working with Antarctica and will allow some visualization of radar data. And then, yeah, obviously making sure that we've got the linkages and Kirsty's at the USAT DC, which provides a great way of linking all these data sets and projects together. Details of languages, we're happy to get community input. Just learning about Parquet at this meeting has been great. There's a lot of different nomenclature that we are still working through in terms of how we call our field seasons. As an aside, a lot of this really parallels what we need to do for Coldex. Coldex is a project where we have a big field season, and then we design the second field season based on the results of the first field season. So we're going to have to turn that data around quickly and communicate it within the Coldex community, indeed the broader community of what we should be doing. So there's a lot of synergies there between Coldex and this. And then I just threw up this slide at the end, for Alice and Julia. And I think this is a really, really excellent product that's mostly open source as I understand it. I've already been using it to go in and look at the areas between South Pole and that data for informing Coldex. There is elements of the fragmentation here because it's only vast data, like the current Croesus thing is only the Croesus data. So we're trying to span across that, but we do understand that there are institutional imperatives to make sure your data is distinct. So we're trying to reconcile those institutional boundaries, which, if we treat it correctly, will make the community stronger. And this is my last slide. So.